And what that means is that it's symmetric about the origin, so that the symmetry is about the origin here. And if we were to take and evaluate sine of negative x, that would be equal to negative sine of positive x. All right. Well, that was a really good investigation into the sine curve. Now what I'd like to do for you is plot the cosine functional values on the coordinate graph in the xy plane. So let's take a look. First of all, you'll look at this and you'll say, wow, it looks very similar to the sine curve, which is to say that it has the same basic shape. It looks as though it repeats, which in fact it does, because it has all of those same characteristics as the sine. I won't take us through all of the points, but let's pick a starting point and look at, for instance, 0 for the arc length, which is our x value, and the cosine of 0 is 1. Pi over 2 is 0, which would be this point right here. Pi is negative 1, right here. 3 pi over 2 is 0, which is right there. And if I go back to 2 pi, of course, 2 pi is the same as 0. Cosine of 0, cosine of 2 pi are both 1. So we get this very smooth curve through those points. Similarly to the cosine, the sine, cosine begins to repeat. And hence you can see, if I go into the negative values of the x, that we get the same exact curve on that side. That leads me to tell you about the domain. As you probably have figured out already, the domain is the set of all real numbers. The range, as you probably have figured out as well, is the same. That is to say that the cosine ranges between negative 1 and positive 1 inclusive. The x-intercepts this time happen at different points, but again, they are repetitive in that they are the odd integer multiples of pi over 2. Odd integer multiples. In this particular case, the cosine is an even function. That is to say, it has symmetry with respect to the y-axis, and we would write that cosine of negative x is equal to the cosine remaining positive cosine of x. All right. We have just seen the graphs of the sine function and cosine function, which we consider as the basic functions. Since they exhibit the same behavior, either graph is called a sine wave or sinusoid. Now, we show how we can have, find new graphs by stretching or shrinking the basic graphs, either vertically or horizontally. We've also looked at shifting graphs vertically as well as horizontally. Let's take an example. Graph y equals 2 sine x and compare it with the graph of y equals sine of x. Well, what I will do for you is first draw the graph of y equals sine of x. What's good is to label the key points. Remember that the sine has intercepts at multiples of pi, integer multiples of pi. And that halfway in between, so for instance pi over 2, is when it reaches its height of 1. Or in the case of negative pi over 2, it reaches its minimum value of negative 1. So if I were to lightly draw the graph as a dotted line for the sine curve, there it would be. Well, what about y equals 2 sine of x? Putting a whole number in front of the function, remember, stretches the graph vertically. So this coefficient of 2 stretches the graph vertically. And therefore, what I would have is, instead of maximum and minimum values of 1, I would have maximum and minimum values of 2. So here it would go up to 2, here it would go down to negative 2, and here, which by the way is 3 pi over 2, and maybe you already knew that, it would go down to negative 2, positive 2. So let me draw that graph for you in a different color so that it stands out. The graph will have the same x-intercepts because stretching it vertically does not change anything along the x-axis where the y value is 0. So it has the same intercepts. Now, what we just did is we worked with something called the amplitude of the sine curve. The amplitude of the sine curve is defined to be half of the distance between the maximum and minimum value. So for the regular sine curve, remember the max value is 1 and the minimum value is negative 1. So halfway between those two, that's a total distance of 2, halfway is 1. So the normal amplitude for just y equals sine x is 1. So the amplitude for what we just looked at, y equals 2 sine x, would be equal to 2. Let's formally define amplitude. The graph of y equals a times sine x, or y equals a times cosine x, with a not equaling 0, will have the same shape as the graph of y equals sine x or y equals cosine x, respectively, except with a range of the interval absolute value of negative a, comma, absolute value of positive a, which is to say that the amplitude is equal to the absolute value of a. Well, now it's time for you to try a problem. So I would like you to graph y equals negative 3 cosine of x over the interval negative 2 pi, comma, 2 pi inclusive, and then give the amplitude. Pause the video while you work on this problem, and when you are finished, restart the video to check your solution. Welcome back. Let's find out how you did with graphing y equals negative 3 cosine of x.